Hello, I wanted to work on gameplay, but I don't have a mech generated yet. I need to build a mech in Blender. So we're going to work on optimization today a little bit. We're going to optimize our chunks so that they don't cause quite as much havoc when they generate. The core problem with our chunks generating is actually this calculate map from scratch. What happens is a whole bunch of chunks will pop into existence at once, and this isn't a coroutine, so it'll get calculated all at once. So all of them will just hang there on that function. I have the problem that my computer is a bit of a beast, so it's actually quite difficult for me to see the delays this causes. So what we're going to do is we're going to go ahead and put this create visual mesh. This can go here in. We have to basically retrofit. We're gonna take this create visual mesh and we're gonna turn calculate met from scratch into the coroutine instead. So where are you? Come on. There you are. There you go. So we've got this IE numerator that we need to do. So let's go ahead and do that. You are now an IE numerator. And we also need to do this yield return 0. So let's go back up here and put that here. But what we also want to do is we want to turn this back into just an ordinary function. Because what we're going to do is we're going to call it here. So up here, we don't need to call that at all. We can just say start coroutine blah. Alright, so let's go ahead and see whether or not that has any. Oh yeah, it has lots of errors. Oh, maybe they both need to be coroutines. Because we are in fact calling that several times, yeah. We call create visual mesh several times, so we're going to need to have them both be coroutines because visual mesh is recalculated whenever we change a brick around. There we go. And it doesn't work. So the question is, why didn't it work? And we have to look into the chunk and see what it has to say for itself. Switch it over to debug mode, and that will let us see. Oh, it doesn't have any way to represent the three-dimensional array. That's right. So what the problem probably is that the visual mesh is not being generated, but we do have the bricks. So to test that, let's go ahead and put in a debug.log created map and debug.log created visual mesh. It says it's created visual meshes, but obviously it is wrong because none of these have been properly created. Oh, of course, no, why would that happen? I can't imagine that this is the problem. Let's go ahead and try it out, though. Yeah, it was. Alright, so if you call that without... I had thought we could just get away with ignoring the fact that it was an asynchronous function, since we were already in an asynchronous thread, but I had thought wrong. So, as you can see, we're walking around, and any delay you see here is pretty much just my camera. I have a really hard time, the video recording that is, I have a really hard time getting any delay out of this. Now those of you working at home will probably notice some delay. I do feel some small amount of delay, but it's on the order of maybe 0.2 seconds. So the problem with the asynchronicity is that it is not a background task. It chews up your processor, and therefore you still get these nasty delays with the frame rate dropping. So what we want to do is we want to make it so that the various things we're creating, the various chunks we're creating, only create one at a time. And what that means is we actually want to queue up chunks. Now, normally I would use an event for this, and I'd have them sign up for the event and then knock it off, but I'm just going to go ahead and use a list for this particular situation. So when we start, we say chunks weighting dot add this, and then then what we need to do is we need to say if chunks weighting dot count equals 1, or I guess it's probably a little bit better to say if chunks weighting 0 equals this, then go ahead and do that. So that means that basically we only calculate this when we are the first thing on the list. Of course, that means that we'll only calculate the very first chunk, because that's the only chunk that's ever going to be the first on the list, because we add ourselves to the chunk and then we're the first on the list and all the other ones come behind us, and we're not clearing ourselves out. So what we need to do is, after we're done creating a map from scratch, which we are down here, we may need to yield to that start coroutine. I'm not entirely sure. We'll figure that out later. So when we do this, what we want to do is we want to remove ourselves from the list. So we say chunks weighting dot remove this, and now we're no longer the first on the list. So what do? We say if chunks weighting dot count count is greater than 0, then start coroutine chunks weighting dot chunks weighting 0 dot calculate map from scratch, and it is public, so that works fine. The only problem with this is that we may run into situations where the yield system fires at awkward moments, and I think that's what we're seeing now. Well, we're definitely seeing it pop in much more gracefully. Well, I don't know. It's hard to tell because of the yield system. The problem with Unity is that their asynchronicity doesn't actually use proper thread control. And so I have a hard time keeping track of what it's actually doing. For example, I don't know, we may want to put this here. No. Alright, so here we are facing one of the problems I knew we were going to face. So now it's working correctly. The problem is that getByte only works once we have a map. So if a chunk has been created but hasn't had its map generated, then its neighbor might go first, and its neighbor will say, "Hey chunk, you exist, so tell me what your map points are." And this chunk has to say, "I don't know, I just don't know." But instead of saying "I don't know," we're going to do it as if it was exactly like this. So when we do this getByte, when we have the problem, it is here, return map XYZ. What we actually need to do is, if we don't have a map yet, then we need to return what we kind of think it's going to be in general. So we say we can put this out here. It doesn't have to be up there. There we go. This can go, there we go. So we get the world pause, and then we can say if map, I guess we should probably just have an initialized. Yeah, that's probably best. Protected bool initialized equals false. And then down here, in our calculate map from scratch, we say initialized equals, oh, I spelled it wrong, didn't I? Brilliant. And so down here in getByte, we say if not initialized, then return the theoretical byte. We don't know what our byte actually is because we haven't got a map yet, but we can return our theoretical byte. and that should take care of that error. Yep, there we go. That's how we want it to be. So is that what everyone wanted to see? That nice pattern. Now, if you are someone who understands programming at a pretty high level and haven't been lost by the basics of what I've been doing, then you can start to experiment and learn exactly. You don't even have to experiment; just go read up on how exactly the threading works in Unity, or rather, not the threading, the asynchronicity works. I've done a lot of asynchronous coding in my life, but I generally don't use the system, the method they're using, so I'm not entirely sure exactly how it works. And it may very well be that right now I've got it set up so that it calculates the map of the next chunk while simultaneously calculating the mesh of the previous chunk, in which case you'd see a little bit more slowdown than you might want. Still, this was a pretty straightforward episode, and I hope everyone enjoyed it. Next episode, I'll probably do a little bit more optimization by showing you how to get rid of chunks we don't need anymore. Um, but maybe I won't do that quite yet. No, let's leave that for later. So I'll try and make a mesh, a model for my mech, and maybe we'll do a little bit of gameplay. Don't know. We'll find out.